Welcome to Care Coordination and Interoperable Health IT Systems, Principles and Technology of Interoperable Health IT, Lecture C. This unit will cover the following learning objectives. Number 1. Name and define types of interoperability. Number 2. Explain the complexities of semantic harmonization and the benefits of using standards. Number 3. Describe and contrast intra- and inter-organizational interoperability. And number 4. Identify and discuss common types of tools and technologies used to solve health interoperability problems. In this lecture and in the next lecture, we will be covering healthcare interoperability tools and technologies. You will be able to identify and discuss the common types of tools and technologies used to solve healthcare interoperability problems. Interoperability tools can help to simplify implementation. The main types of tools used are Interface Engine, Enterprise Master Patient Index, Terminology Management System, and Health Information Exchange or HIE software. These are sometimes referred to as middleware. There are also tools that can help build, document, and validate standards implementation. There are vendors who offer one or more of these products, and there are also several free or open source offerings. An interface engine, which is also sometimes known as a message broker, is a term used to refer to a kind of middleware application that is used to transform, route, clone, and translate messages. In this picture, you will see a picture of 4 different hospital systems: the patient administration system, the electronic health record, the laboratory information system, and the clinical data warehouse. In this picture, we have a hub-and-spoke model where all the systems are sending data to the interface engine and getting their feeds from the interface engine. The picture depicts how interface engines simplify and organize interoperability by reducing the number of connections between systems that need to be managed, and by creating a central management point. Interface engines are often used by providers to help manage their interoperability needs. They are often used by health IT software vendors to provide a configurable layer in their products to solve gaps in interoperability between their own products as well as products produced by others. An interface engine will often have the following capabilities. It will usually act as a hub in a hub-and-spoke model, or as a hybrid with multiple hubs. Interface analysts are people who implement interoperability based on user and business requirements. The interface engine provides them with robust capabilities to build maps, filters, translations, and routing rules to achieve interoperability between systems that are not fully plug-and-play. The interface engine provides standard connectors and formats to facilitate implementation. For example, most interface engines supply pre-built HL7 v2 message structures. The interface engine queues messages so that in the event that a receiving system is unavailable, the data will not be lost. This is referred to as, quote, store and forward capability, unquote. The interface engine keeps audit logs of all message traffic in case messages need to be replayed because they are lost, they need to be fixed, or in case there are production issues that require further inquiry. Modern interface engines provide sophisticated monitoring capabilities, allowing for 24/7 support of all the interfaces that flow through it. Interoperability outages and problems are a serious issue. Therefore, sophisticated monitoring capability is one of the most important features of the interface engine. If an interface is not functioning properly, alerts are issued. Support personnel can start and stop interfaces and monitor interface operations. There are several vendor offerings available, and there is also an open-source interface engine called Mirth. The following quote is a nice summary of the role of the interface engine. Quote, "In today's connected healthcare environment, the role of an interface engine should be to enable faster deployment cycle times of high-quality interfaces using people who have analyst-level, workflow-based skill sets. With healthcare data flowing through it, an interface engine should ease connections to remote care facilities, e.g., physicians' practices, labs, radiology centers, etc., and leverage the data to improve operations and workflows. Now let's talk about another important tool in our toolbox, the EMPI. First, let's discuss patient identification. In smaller healthcare organizations, there is a single authority responsible for assigning a unique identifier to all patients in its domain. At a hospital, the assigning authority is usually the Health Information Management Department, or HIM. It is sometimes called the Medical Records Department, and the IDs are often called the Medical Record Number, MRN. Sometimes there can be errors in assignment, such as duplicate IDs, or IDs assigned to the wrong person. Errors can happen within just one assigning authority. A bigger enterprise might include several hospitals, care facilities, and/or physicians' groups. One example might be an accountable care organization, or ACO. Each facility or group within the larger organization may have its own assigning authority for its own patient identifier. In addition, there might be a need to manage other patient IDs, such as insurance IDs. There is a need for a central enterprise-wide patient identifier to link all the patient indices for a patient together so that a patient's records can be found and linked across the organization. An Enterprise Master Patient Index, or EMPI, is a system that owns and manages patient identification across an enterprise. It generates and maintains an enterprise-wide unique identifier for a patient. It serves as the single source of truth on patient demographics for the enterprise. It maintains the association between all the identifiers for a patient that exist across the enterprise so that patients can be matched and records linked. It provides tools to allow EMPI quality analysts to maintain the quality of the index by resolving potential duplicate records and other quality issues. So let's talk about use cases for an EMPI. One use case is to find patients and their information, allowing for care coordination across the continuum of care. For example, a record lookup in a health information exchange can reduce double entry and provide a better experience for the patient. Imagine that wherever a patient presents, he or she is actually recognized, and his or her history is retrieved instead of having to start from scratch, re-enter forms, and re-enter data, and a clinician is not able to get to all of those records. An EMPI can prevent misidentification, which encourages safe care. If an integrated delivery network had several facilities that had their own patient IDs but wanted to share a laboratory system, an EMPI would allow for the patient to have a unique identifier within the shared system. An Enterprise Master Patient Index should be a system that owns and manages patient identification across an enterprise. There are actually two models you could use to do EMPI, active and passive. Today's EMPIs are a combination of both approaches. The active model is one where the patient identity source system allows the EMPI to truly manage identification and own the demographics. It is used in some intra-organizational settings. It has fewer duplicates and incorrect matches, and we will see why in the next few slides. The passive model is where the patient identity source system does not allow the EMPI to manage identification completely. While it may provide these IDs to the EMPI, often what the patient identity source system is doing is local searches. Often a health information exchange has to deal sometimes with the passive model integration, but an HIE might do a combination of both passive and active models. There are numerous vendor solutions out there, and there is also an open source EMPI. So let's talk about that active EMPI model, where the owner of the demographics is the EMPI. The next few slides are actually from an EMPI implementation at the New York Presbyterian Hospital. However, they apply to EMPI designs in general. From within the patient management system for one assigning authority, the registrar searches the EMPI for the patient instead of searching for the smaller local database, which does not know all patients in the enterprise. An API call is made to the EMPI and brings back all possible candidates. If the patient's EMPI record is found, then the registrar updates their EMPI data. If not, the registrar creates a new EMPI record for the patient and assigns their medical record number, or MRN, to that facility. The MRN number and data are then fed back into the local patient management system, and the registration continues. This prevents duplicates from being created across the enterprise and ensures a single owner of patient identification and demographics across the enterprise. Once the registration is complete, the patient management system will most likely generate a message with the new patient information, including the EMPI number, across an interface to all interested systems. Now, the passive EMPI model, which is often something that needs to exist, is different. This model is one where the EMPI is not able to be the owner of the data. Instead, the registrar on a local patient management system will only search their local database and will not be able to see if the patient already exists somewhere else in the enterprise. The registrar performs a local search and then selects a patient or chooses to create a new patient. Then the registrar completes the registration in the patient management system, and an administration discharge transfer message is sent to the EMPI. The EMPI uses a special matching algorithm to determine if the patient already has an EMPI record. If it finds a match and has a high confidence that it's the same patient, it automatically matches the patient and updates the EMPI with the new local ID. If no match is found with high enough confidence, the EMPI creates a new EMPI record for the new patient. It then provides the EMPI number back so that the ADT, or Admission Discharge Transfer, interface message can be changed to include the EMPI number. The ADT transaction with the EMPI number is then forwarded to all systems requiring the EMPI number. If likely matches were found, but without enough confidence to automatically assume a match, then an EMPI quality analyst is alerted for a potential duplicate to review. Without a single national patient index, the challenge of patient matching is especially difficult between unaffiliated organizations. If an EHR receives a patient summary from an unaffiliated provider, it needs to perform matching to determine if it already has the patient in its EHR. The provider cannot use the patient ID sent by the referring physician since it is not a shared ID. Instead, it must rely on demographics to attempt matching. Health Information Exchanges, HIEs, help by providing a community-level EMPI that links patients across the organizations in their exchange. IHE-PIX-PDQ is a standard profile often used by EMPIs to communicate about patient identification across enterprises and in conjunction with HIEs in a standard way. To understand EMPIs, it is a good idea to study the IHE-PIX-PDQ profiles. Since there is no national patient ID, you would need a way to link patient IDs together. Integrating the Healthcare Enterprise, IHE, calls this Patient Identifier Cross-Referencing, PIX. It is also known as Enterprise Master Patient Index, or EMPI. This picture is a diagram showing how IHE expects EMPIs to communicate patient ID information with other systems. It shows the actors in the IHE, Patient Cross-Referencing Profile, also called PIX. EMPIs play the role of Patient Identifier Cross-Reference Manager. A patient identity source is the role played by any entity that assigns identifiers, like a hospital's medical records department. A patient identifier cross-reference consumer is an organization that needs the EMPI or needs to look up IDs from different organizations. This picture shows how the EMPI collects all the local IDs from patient identity sources, links them together, and provides the linkages when requested by the patient identifier cross-reference consumers. The IHE Patient Identifier Cross-Reference Profile is important because it provides a standard way for EMPIs and systems that need EMPI information to communicate. EMPI vendors will often display in their website and in their advertising that they conform to the IHE PIX profile. The IHE PDQ profile is also usually implemented by EMPIs. PDQ stands for Patient Demographic Query. This profile says that the EMPI is able to respond to queries for patient demographic information, another useful EMPI function. Note that the PIX and PDQ profiles both use HL7 standards. If you are selecting an EMPI product, it might be a good idea to ensure that they conform to the IHE PIX and PDQ profiles. The Enterprise Master Patient Index is an important concept because it provides a way of matching and linking patients across disparate systems. The same need exists for other entities within the healthcare ecosystem. Examples include people or organizations associated with a patient, like the insured, the caregiver, or their next of kin. Providers are another important entity that need to be tracked across systems. Healthcare devices might be another example. Technology like EMPI can be used to provide similar matching and linking, and index capabilities for these other entities. This concludes Lecture C of Principles and Technology of Interoperable Health IT. In this lecture, we began our coverage of common healthcare interoperability tools and technologies. The major tools and technologies covered include Interface Engine and Enterprise Master Patient Index. We will continue with tools and technologies in Lecture D.